वेलकम बैक टू इसके वन के सनवा बैक अगेन विद अनदर वीडियो ऑफ माइन। एंड आज हम लोग एक और मैथमेटिक्स के टॉपिक के डिस्कशन करेंगे। इट इज गोइंग टू बी अबाउट चेंज ऑफ वेरिएबल्स कि कैसे आप जब पार्शियली डिफरेंशिएट करते हो सो यू कैन बेसिकली मेक अ वेरिएबल चेंज। एंड ये जो डिफरेंशिएशन के बाद आपका जो फंक्शन आपको मिलता है ये डिफरेंट सेट ऑफ वेरिएबल्स में आप लिख सकते हो। एंड इट इज समथिंग लाइक वी आर गोइंग टू स्विच फ्रॉम कार्टेशियन कोऑर्डिनेट्स टू मे बी स्फेरिकल कोऑर्डिनेट्स। सो आई एम गोइंग टू जस्ट शो यू कि कैसे वेरिएबल चेंज आप कैरी आउट करते हो while writing the equations themselves. So it is always possible that you can first solve the equations and do the differentiation, and well you can afterwards switch from Cartesian coordinates to whatever kind of coordinate you want to. लेकिन हम लोग यहाँ पे डिफरेंशिएशन की कैसे ये जो डिफरेंशियल्स हैं ये खुद डिफर करते हैं, ये जो पार्शियल डेरिवेटिव्स हैं ये खुद डिफर करते हैं व्हेन यू आर मेकिंग अ चेंज ऑफ वेरिएबल। सो लेट्स गेट ऑन टू इट। इट्स समथिंग लाइक पहले वी आर गोइंग टू जस्ट राइट द फॉर्मूला कैसे चेंज होता है। इट्स अगर आपके पास एक फंक्शन f है एंड यू आर पार्शियली डिफरेंशिएटिंग इट with respect to some uj out there, you can consider that way, and this must equal the summation over all i's of the partial derivative of f with respect to xi times the partial derivative of xi with respect to uj. So what we have written right now is just the chain rule, right? तो हम लोगों ने चेन रूल का यूज किया एंड व्हाट इट एक्चुअली मींस इज कि अगर मेरे पास एक फंक्शन है f एंड ये फंक्शन में एक्सप्रेस कर सकता हूं एज वेरियस काइंड्स ऑफ, इट कैन बी अ फंक्शन ऑफ मे बी xi. सो हियर यू हैव x1, you have at same place xi and it just continues, कहीं xn हो सकता है। तो आपके पास एक फंक्शन है एंड आप इस सेट ऑफ कोऑर्डिनेट्स में से रिप्रेजेंट कर सकते हो। इफ इट इज कार्टेशियन कोऑर्डिनेट्स सो हियर यू नो इट इज x y एंड z, तो आप इस फंक्शन को x एंड y एंड z में रिप्रेजेंट कर सकते हो। बट यू कैन आल्सो स्विच कोऑर्डिनेट्स, राइट? बिकॉज़ वेल यू नो कि ये जो कार्टेशियन कोऑर्डिनेट्स स्फेरिकल कोऑर्डिनेट्स पे डिपेंड कर सकते हैं एंड उनके बीच स्विच होता है एक काइंड का, यू नो यू कैन ऑलवेज स्विच बिटवीन देम। So in that case you can also write कि जो function है f, this might as well be written in terms of these other coordinates that you can have. So you write maybe u1 as some point uj right here and at some point um you could write. अब हमें बस देखना ये है कि अगर मैंने इस फंक्शन को f को डिफरेंशिएट किया with the coordinates themselves, and when I do so with respect to this uj right here, कि यहाँ से हम लोगों ने एक particular coordinate choose किया है and I equate that with what? Well, I can equate with that the summation over all i's, the partial derivative of f with respect to any individual variable, any individual coordinates times the partial derivative of this individual coordinate with respect to this one coordinate right here. And I think this should be very self-evident itself. I think that should be the case, क्योंकि if you see the chain rule, अगर आप chain rule को देखते हो and you notice कि well यहाँ पे जो xi है and uj है they should be functions of one another. So you write out the chain rule and you accept the fact that xi and uj are well functions of one another. So you can always have them as the variables that they are depending on like one another. You can write the chain rule in this form and this is basically the equation जिससे change of variables होता है। Now we could specifically consider this one कि when you want to switch between spherical coordinates and Cartesian coordinates as of this particular case, that you have for instance x and y axis and you have over here this row. This is rho at an angle of phi. तो when you consider rigid body motions, तब उस केस में you know कि instead of x and y the Cartesian coordinates rigid body motions में you are more likely to use rho and phi. You are more likely to use well spherical coordinates. And you know how the relations go. Well here this you have as rho cos phi, this you have as rho sin phi in that these are x and y. अब यहाँ पे this is actually a problem in really Hobson and Benz. I can say that for the reference कि if you have a function f जिन्हें in terms of Cartesian coordinates, well you are representing that and this is a function f, it is a function of x and y, right? लेकिन you know that x and y are well functions of rho and phi, they should also be a function of rho and phi. तो यहाँ पे अब हम लोग इस फंक्शन को चेंज कर देते हैं, इवन दो व्हेन यू आर कैलकुलेटिंग देम न्यूमेरिकली और व्हेन यू आर ट्राइंग द प्रॉब्लम, सो दे आर एक्चुअली द सेम थिंग. सो दिस इज अ फंक्शन g of rho and phi. Then you say कि अगर मेरे पास है एक फंक्शन f which is well f x y, so it is depending on x and y in some manner and you know that x and y are depending on rho and phi in some manner, then you say कि ये f बेसिकली रो एंड phi पे भी किसी मैनर में डिपेंड करता है. तो अगर x and y में as this in this manner डिपेंड करता है, then it depends, it is written in terms of rho and phi maybe as a g of rho and phi. So f x y and g rho phi are actually the same things, but since they will be written in two different forms क्योंकि हम लोगों ने change of coordinates करा है, so you will basically see कि अब हम लोग एक different notation लिखना चाहते हैं. So this problem in Rayleigh Hobson Benz is about that the second partial derivative of f with respect to x plus the second partial derivative of f with respect to y, what is it going to look like in these spherical coordinates in terms of this g function that you see right here. तो कैसे इसे हम लोग relate करेंगे with respect to g or with respect to the partial derivatives involved in g. So that is our question. तो अब हम लोग क्या करते हैं, well what you can see right here is since we have to relate it to g, first thing again very important that f x y and g rho phi are again equivalent of one another. Now you want to find this d2f over dx square, we need to first find df over dx in terms of well this g thing right here. So what we actually now want to find is कि अगर मैंने यहाँ पे लिखा है कि d over duj, now what is this particular thing? Well we are switching to spherical coordinates, so that can be rho and that can be phi, but since it is actually this expression that we are transforming, हम लोग इस expression को transform करें. Let's consider right here x and you write that it is d over dx of this function f. I'm writing it here to actually differentiate it. Okay, so that can be a bad pun. So to actually separate it from this operator d over dx, तो यहाँ पे ये मैंने d over dx लिखा है and ये act कर रहे हैं f पे. So when I actually write right here df over dx, that can be a little confusing according to what we are going to do next. You say that is a summation over all I. यहाँ पे हमारे दो अलग coordinates है rho and phi, so that's gonna be 2. You write it as d over, I am writing this term first, this second, क्योंकि f को again हम लोग बाद में लिखेंगे क्योंकि it is actually the operators जिसके साथ हम लोग deal कर रहे हैं. Why so? You're gonna see that next. Here you are going to write this is d of rho over dx times d over d rho acting on f. Now what you can do is f को as a common function बाहर ले लेते हैं, plus में you write that this is d of phi over d और d of यहाँ पे x ही है d over d phi, this whole operator, ये पूरा एक operator बन गया जो कि f function पे act कर रहा है and we are actually dealing more with operator than the actual functions right here. And then we can make it act on any function f or g whatsoever and you can just find the correct relations. तो ये चीज हमें मिल गई. Now the thing is कि हमें d rho over dx calculate करना है. So how do you do that? Well you know कि rho is going to be well x square plus y square whole to the power 1/2 and you know कि phi आपका हो जाएगा tan inverse y over x. So what we are doing is this d rho over dx, well you have a half right है, यहाँ पे chain rule apply कर सकते हैं. So here we have a change of variables equation जो कि chain rule से ही आते हैं. Another chain rule thing right here, and it is quite easy to find that this is x over x squared plus y squared, and that is equal to, well, cos of phi. And similarly you can find d phi over dx, and that thing you find when you differentiate this tan inverse y over x. Another chain rule operation right here, and again easy to find, it is minus y over x squared divided by 1 plus y over x squared, which can be written as minus sin phi over rho. Now ये हम लोगों ने d rho over dx and d phi over dx evaluate किया, and well it can be a little symmetrical mathematically कि अगर हम लोग को ये भी इक्वेशन के साथ डील करना है, we want to find out, well, this d over dy operator acting on f partially again, so you are going to need d rho over dy and d phi over dy. So let's calculate that d rho over dy. So you can always exploit symmetries, right? That can be even mathematical symmetries, and that way you can write that this will come out y over x squared plus y squared. So this you write as sine of phi, and well you can always write that d of phi over dy, well this is going to be this d of tan inverse y over x over x. previous case में यहाँ पे जो वेरिएबल हम लोग का एक्चुअल में वेरिएबल था, नॉट द कांस्टेंट, that was in the denominator, in this case numerator. This is going to be cos of phi over rho. अब यहाँ पे ये हम लोगों ने चार डेरिवेटिव्स कैलकुलेट कर लिए. नाउ द थिंग इज यू एक्चुअली नीड द सम ऑफ these terms in these two terms in terms of g. So you say, well, that d2f over dx squared is what really? It is d over dx acting on df over dx, which can be now written as d over dx acting on d over dx acting on f, right? अब यहाँ पे हम लोग बेसिकली क्या करते हैं, यू कैन क्लियरली सी कि आई कैन फाइंड व्हाट द d over dx acting on f is. दिस इज बेसिकली, अब यहाँ पे हम लोग ऑपरेटर अलजेब्रा थोड़ा करते हैं. यू जस्ट टेक आउट द f थिंग राइट हियर, यू टेक आउट द f थिंग, वो हम लोग बाद में पुट कर सकते हैं. वी आर मेनली डीलिंग विद हाउ द ऑपरेटर्स आर themselves gonna, well, whatever operations are happening, so as of the additions and multiplications, this is d rho over dx जो कि हम लोगों ने यहाँ पे किया है. so this is cos of, well, cos of phi, and then there is a d over d rho, and then there is plus d phi over dx, so minus sin phi d over dx, sorry, minus sin phi over में rho हो गया, and then you have a d over d phi, right? तो ये बेसिकली हमारा हो गया, ये d over dx क्या होगा. Similarly, the d over dy can be written as, it can be written as now, जैसे हम लोगों ने इस टर्म को लिखा था वैसे ही लिखा जाएगा, एक्सेप्ट अब यहाँ पे जो डिफरेंशिएशन होगा x की जगह y के रिस्पेक्ट में होगा. सो यू हैव d rho over dy, so it is now sin of phi d over d rho plus cos of phi over rho d over d phi. So this is d over dx and d over dy, they are only operators. And now you can check that what is d2 over dx square and d2 over dy square. So you say that this d2f over dx square. अब since हम लोग according to whatever operator things that we have seen right now, जो कि अब हम लोग रो एंड फाई के रिस्पेक्ट में डिफरेंशिएट कर रहे हैं, जो ऑपरेटर्स हैं रो एंड फाई के रिस्पेक्ट में एग्जिस्ट कर रहे हैं, जब हम लोग एक्चुअल में इन डिफरेंशिएशंस को कैरी आउट करेंगे, यू आर गोना हैव टू पुट नॉट एग्जैक्टली एफ एक्स वाई, बट यू आर गोइंग टू पुट जी रो फाई, राइट? क्योंकि हम लोगों ने अब इन इक्वेशंस को रो एंड फाई के रिस्पेक्ट में बेसिकली लिखा है, all these operators. So and since you know that the two are actually equivalent, you can as well replace them, especially जब आप ऐसे लिखोगे, you have to replace them because the differentiations are happening according to rho and phi, and these are partial derivatives in fact. So you say that this d2f over dx squared should well be cos phi d over d rho minus sin phi over rho d over d phi, and this is now acting on itself, so it is cos phi again d over d rho minus sin phi over rho d over d phi, and this is now acting on g, which is actually the same as f, लेकिन here the derivatives are of rho and phi, तो इसे हमें g जो कि rho and phi का फंक्शन है लिखना होगा. Now what is this? Well, this you can find as cos phi d over d rho, so you can clearly see this thing gets squared, cos square phi d2 over d rho square, then you have this multiplied with this minus cos of phi sin phi over rho, this is d2 over d rho d phi, then you have this minus again cos phi cos phi sin phi over rho d2 over d rho d phi, and then you have a plus right here, that is sin square phi over rho square d2 over d phi square. तो ये हमें d2f over dx square मिल रहा है, and this all of this is now acting on this function g, right? In fact ये जो आप दो expressions आप देख सकते हो, well this is something like cos phi sin phi over rho, यहाँ पे cos phi sin phi over rho both are multiplied the individual terms by d2 over d rho d phi, and we are of course using the fact that whether you first differentiate, अगर दो आपके ऐसे ऑपरेटर्स डिफरेंशियल ऑपरेटर्स साथ में है, so it is like d over d rho and acting on d over d phi, that is the same as d over d phi acting on d over d rho, and of course that with the functions of, because otherwise it won't really make any sense. तो ऑल्दो हम लोग ऐसे ऑपरेटर अलजेब्रा कर सकते हैं, बट इट डजंट मेक एनी सेंस जब तक हमें उसे किसी फंक्शन पे यूज नहीं करना है. Now we could same way find d2f over dy square, right? तो ये d2f over dy square क्या होगा? Let's write that, and we are gonna add both of them afterwards. This is well going to be, now what is df over dy? df over dy अगर हम लोग देखें, so it should be like this term but replaced with y, एंड ये हम लोगों ने पार्शियल डेरिवेटिव्स एंड पार्शियल डेरिवेटिव्स को इवैल्यूएट करा भी है. इनफैक्ट आई हैव जस्ट रिटन इट राइट हियर, सो दैट्स नो नीड टू गो थ्रू दैट थिंग अगेन. इट इज दिस थिंग ओवर हियर, सो वी से दैट दिस इज वेल sin phi d over d rho plus cos phi over rho d over d phi acting on sin phi d over d rho plus cos phi over rho d over d phi, and this is well all acting on the function g right here. अब ये हमारा जो चीज है, well this is something like sin square phi, let me just write it here, sin square phi d2 over d rho square all under brackets again, plus now this is, you can see this thing right here, this thing sin phi d over d rho, here cos phi over rho d over d phi, so it is coming the same thing again. ये जो जैसे हमारी ये जो चीज अब इससे मल्टीप्लाई होगी, so they're the same things again. You can always write them as 2 cos phi sin phi over rho multiplied by d2 over d rho d phi, and then they are again added by what? They are getting added by this cos square phi over rho square d2 over d phi square. Alright, तो ये जो हमें दो टर्म्स मिल गए, अब हमें इन टर्म्स को ऐड करना है. एंड हाउ डू यू रियली ऐड देम? Well, you can add them in such a manner, well you can clearly see कि एक आपके पास cos square phi d2 over d rho square है. Here you have sin square phi d2 over d rho square. They're all acting on g, remember? So when you add them, cos square phi plus sin square phi will 1 के equal होता है. So upon adding the two of them, you can see this one thing is d2 over d rho square. That is going to be added now by, well, you have this term which is minus 2 cos phi sin phi over rho d2 over d rho d phi, and that is a plus this term which is again the same thing right here, except ki it is positive, so the two are going to get cancelled. Let me make this a bigger. So these two are going to get cancelled with each other, and then you have a plus sin square phi over rho square d2 over d phi square, and here we have a cos square phi over rho square d2 phi. So here you can see it is something like sin square phi over rho square cos square phi over rho square 1 over rho square d2 over d phi square, and this is acting on g, right? So you can clearly get in the end this kind of result कि this is d2 over d rho square plus 1 over. In fact, since यहाँ पे अब हमें ऑपरेटर्स के साथ explicitly बस deal नहीं करने, we have to actually write the function there. So you could write this result that is the second partial derivative of g with respect to rho plus 1 over rho square second partial derivative of g with respect to phi. So I think it really got quite messy in there. लेकिन ये जो हमारा रिलेशन है, जो ओरिजिनल रिलेशन है, this thing right here. So I say कि this should well be equal to, when expressed in terms of these spherical coordinates, the second partial derivative of g with respect to rho plus 1 over rho square the second partial derivative of g with respect to phi. And well, that you see there is a final answer. In fact, I would apologize if there would be something like we have caused quite a mess in here, so there might somehow somewhere come some kind of algebra fault. So if there is some algebra fault, so I would be really sorry for that. Lekin according to what we have done, this seems to be at least our final answer. And in fact the purpose of the video is again to show you कि कैसे exactly ये किया जाता है. So we don't need full-blown precision right here and accuracy. Rather, I want to show you कि कैसे इन चीजों को किया जाता है. How do you actually make a change of variables? And again, ये change of variables differentiation के बाद भी किया जा सकता है. Remember कि when you are solving a problem that is about the change of variables, or maybe you are solving a problem and at the end of the answer आपको इसे एक variable से दूसरे variable में shift करना है. So you will see that well, you have brought the answer in your Cartesian coordinates x and y के terms में, and then what you can do is कि after you have evaluated this in terms of x and y, you see कि x आप rho cos phi लिख सकते हो and y आप rho sin phi लिख सकते हो, and then you can make your transformation and you would arrive the same result as from this equation. But the thing is कि often times जब आप कोई derivation करते हो, so you can, there are always cases जहाँ पे x and y, the not the individual problem itself, but वो पूरा situation, वो पूरा case खुद में ही ज्यादा easy हो जाएगा x and y के बजाय rho and phi के terms में solve करने में. So in that case, the equations that you could have written as d2f over dx square plus d2f over dy square, you need to write them now in this form, right? So you might think, well, what is the purpose of it if we can just solve it in terms of x and y and then make the transformation? So the purpose is that you can often exploit circular or spherical symmetries, which are really a nice thing to do in certain situations, and when you can actually do that, it's quite beneficial actually. But in order to do that kind of thing, जो कि काफी beneficial हो सकता है, you need to use instead g right here. You need to instead use the function of rho phi, and again it depends on the individual problem itself कि आप कार्टेशियन कोऑर्डिनेट्स यूज करना चाहते हो या फिर स्फेरिकल. बट वेल यू नो कि रोटेशन के केसेस में यू आर ऑफन यूजिंग स्फेरिकल कोऑर्डिनेट्स इंस्टेड ऑफ कार्टेशियन, राइट? So that was, I think, all for today's video of mine, and thanks to all viewers.